Okay, so we've made it to the very last lesson on our polynomial functions. Okay, lesson 6. Now this one here, it says modeling and solving problems with polynomial functions. So example number 1. The volume in cubic centimeters of a rectangular box can be modeled by a polynomial function v of x equals to 3x cubed plus x squared minus 12x minus 4. Okay. Volume, rectangular box. Okay. So when we look at the rectangular box, what does that look like?
Those opposite sides are equal.
Okay, so we have a, oh, yeah, so it would be a box looking like this, right? Just a typical box. Right. So this side and this side are equal, this side and this side are equal. This is your height, right? So this one would be your length, this is your width, and then the height. Because it's a rectangular box, it's a three-dimensional figure, length, width, and height. How can we figure out the volume of the box? The volume of the box would be V, volume, is equals to length times width times height, right? Length times width times height. Now they're saying that, hey, the volume is modeled by this polynomial 3x cubed plus x squared minus 12x minus 4. So the volume is 3x cubed plus x squared minus 12x minus 4. Determine the expression for the other dimension if the height is x plus 2. Okay, that tells us the height is x plus 2. Now, what is the length and what is the width? Right? So how can we figure that the length and the width, given that the height is x plus 2 already? So how do we do that? Yeah, so what we could do, any idea?
You have to give minus 2 to the x values.
Yeah, if we put a minus 2 here, that will give us a volume of 0. Okay. Yeah, so this is one of the factor. Yeah, one of the factor of the polynomial. So what could we do? Yeah, we could do a synthetic division. Yeah. So let's go ahead and do the synthetic division. So if x plus 2 is a factor, then that means x must be minus 2. So let's do that becomes, okay, anything missing? Cube, squared, x, no, nothing's missing, and they're in order, so I can go 3, 1, negative 12, minus 4. Okay, yeah, go ahead. You know how to do synthetic division? Go ahead and do the synthetic division. I'll give you a minute to do that.
minus 5. Not positive 5.
Minus 5.
And 10.
It's going to be negative 10
10 minus 4.
minus 2.
4 positive 4.
Okay. So the remaining polynomial is what? 3x
Minus
5x minus 2. Okay. Now we could factor that out. How what's a factor of that one? So this is a, how can we factor that out? So 3 times negative 2 is going to give us negative 6.
1.
Okay, so factor 3x squared. So what are the factors of 6x squared that adds up to negative 5? So minus 6x plus x minus 2. And then factor by grouping here, factor by grouping. So this is going to be 3x, x minus 2. And then here the GCF is 1, so plus 1 is x minus 2. So the factor would be x minus 2 times 3x plus 1. Okay. So what's determine the expression for the other dimension of the box. So therefore, okay, I'll just do it here. Therefore, the other dimension are x minus 2 and then 3x plus 1. Okay, that's our answer. Is that okay? Yeah? Okay, good. Take a look at number 2, example number 2. You want to write that down?
How do you know which one's which there?
It doesn't matter.
No, it doesn't matter.
Yeah, it doesn't really matter. Okay, was that good? Okay, I'll try to do example 2. Okay, let's read it first. I'll leave it out like that. Example 2, an artist creates a carving from a block of soapstone. The soapstone is in the shape of rectangular prism. Okay, again, it's a rectangular prism, a box, whose volume in cubic feet is represented by. What are the factors that represent the possible dimension in terms of x of the block of the soapstone? Okay, so an artist creates a block. The soapstone is a rectangular prism. Again, x is represented by the equation. Again, this is a volume one, where x is a positive real number. What are the factors? So they didn't give us any information. We're just looking for the factors of the dimension. What is the length, the width, and the height? So, so what can we do?
Theorem factor?
Huh?
Theorem factor theorem?
Yeah, we're gonna do the factor theorem, yeah, remainder theorem, and then the factor theorem. Yeah, so look for a factors of -8 that will give us a remainder 0. Okay, that's what the remainder theorem is. Okay, so let's go figure that out. V, I'll just put V because this is V. V -1. What's if it the x is -1? Will that give us a 0? That's gonna give us -6 minus, oh, no. That's gonna give us plus 25, -2, -8, okay. So that's not gonna give us a 0, right? So negative, v -1 is not a 0.
Yeah, it's not
Okay.
0.
Okay. So this is not a factor. Okay. Okay, so not a factor. So x plus 1 is not a factor. Okay. What number should we try?
-2.
Try -2? Okay, let's try -2. -2, so that's going to give us 6 times -8 plus 25 times -2 squared, so that's 4 plus 2 times -2 minus 8, so v -2 is going to give us -48 plus 100 plus 4. I can see it's not going to work, right? Yeah, too much positive in here. Okay, so that's not a factor. Okay, what can we try? -4? Okay, let's try -4. Six times -4 cubed plus 25 times -4 squared plus 2 times -4 minus 8. Is that going to give us 0? Yes, 0. Yeah, we found one factor.
-4 is 0.
You have to do that and find all the factors?
Okay, well, we found one. We got to do the synthetic division now, right? So if v of -4 gives us a 0 remainder, what does that tell us? X, therefore x plus 4 is a factor. Okay, we found one factor. We found one factor. Okay, now that we found one factor, what are we going to do next? Hmm? I'm going to do the synthetic division, right? So what's the synthetic division look like? So 6, 25, 2, -8. Okay, so go ahead and try that one. Okay, remember it's already a 0 remainder, so it has to be 0 at the end. Yeah, okay. Yes? Is that what you got? The same one? You got 6, 1, negative 2, 0. So that boils down to 6x squared plus x minus 2. Okay. Now I'm going to go back up here because I don't have room there. And how do we factor that out?
6x plus 2, 6 minus 1
6x
plus 2.
plus 2. So 6x squared plus, okay. So what are the factors?
Minus 3.
That's going to give you my plus 3 and minus 4.
No.
Plus 4.
Minus 3.
Plus 4 minus 3x minus 2. Okay. Factor by grouping. That's going to give us a common factor of 2x. So that's going to be 3x plus 2. Greatest common factor here is minus 1. So it's going to be 3x plus 2. So the factor would be 3x plus 2, 2x minus 1. Okay. Well, we want to know what the possible factors. So what are the possible factors for dimensions? So therefore, v of x is equal to 3x plus 2 times 2x minus 1. What else? What's the other one?
X plus 4.
X plus 4. Yeah, this is the other factor. That's it. Length times width times height. And then you could just say, okay, well, how do I know which is which? It doesn't really matter, right? Is that okay? Yeah. So they're putting it in some kind of a context, and this is what we got.
Sorry, can I just get Jesse a second?
Oh, yeah.
Or just show me?
Okay. Now let's take a look at the next one. Read it first and see if we could figure it out.
Just one, right? No, that's okay.
Awesome. See that one? And this one's very different, slightly different. It says here 3 consecutive odd integers. 3 consecutive, what does the word consecutive mean?
Series.
The series are one after the other, right? And it has to be odd, okay? So 3 odd numbers, and it says it has a product. When we multiply those 3 numbers, they would multiply to a negative 105. And the questions are, what are the 3 integers?
X plus 1 plus x plus 3 plus x plus 5.
Okay.
What about if we take the first one as x and the second one x plus 1?
Okay. Oh, okay. So if we say x, and then you have the next one would be x plus,
1, it will be 4 like
okay,
It would be odd, maybe
okay. Oh, I think your thinking are in the right track. You were in the right track, right? Because if you say x, and then the other one would be
x plus 2,
x plus 2,
x plus 4, x plus
x plus 4, okay, okay, good. But this one doesn't guarantee that it's an odd number. It could be an even, and then the next even, and then the next even. Okay, so this is a nice way to think about it, but it doesn't guarantee an odd number.
What about x plus 1, x plus 3, x plus 5?
Okay, so let's try this one. Okay, that's a good thought. X plus 1, x plus 3,
X plus 5.
x plus 5. Okay. Now, if x is an odd number, if we add 1, will give us an even number, right? Now, if this is 3 plus 1, that's also going to be an even number. Now, if this is 4 plus 1 will be an odd number, right? Okay. So, this one doesn't guarantee an odd number.
What about x?
How do you know that?
X to the power of 3, x to the power of 5.
No, that's a thought, but to the 5 won't be consecutive anymore. Yeah, good thoughts. Okay, I'm gonna actually borrow this idea. I'm gonna do one thing though. Okay, to this one, almost. That doesn't guarantee an odd number, right? Because if x is 2 plus 1, oh, that was an odd number. But if x is 3 plus 1, that's going to be an even number. So I'm going to borrow this idea, and this is what I'm going to do. Okay. Will this always give me an odd number? No matter what the x is. Okay, let's try it again. If x is 1, 2 times 1 plus 1, does that give me an odd number?
Yes.
Yeah. If x is 2, does that give me an odd number?
Yes.
Yeah. So it doesn't matter what the x is, 2 times x will because it's multiplied by 2, will always turn that number to a positive number. But since we added a 1, it will force it to be an odd number right off the bat. Okay? Is that okay? So that's our first odd number. Our first odd is 2x plus 1. Now if 2x plus 1 is our odd number, what's the next odd number? Huh? 2x plus 2?
Plus 3. It says forward.
4x.
2x plus 3. Yeah, 2x plus 3. Okay. Yeah. And then what's a third number? Third odd.
2x plus 5.
2x plus 5. You got it. Okay. Is that good? No matter what x value you put in, it's going to be second, third, and okay. So now that one gave us a thought. Okay. Good. Now it says here we have to have a product of these 3 odd integers. It adds to negative 105. Okay. So product is 2x plus 1 times 2x plus 3 times 2x plus 5 will give us negative 105. Okay. So what are we going to do next? What we're going to do is we're going to make one side equal to 0 to solve for x. Okay, we're going to make one side equal to 0 to solve for x. But how do we do that? We're going to expand it out. Let's expand this one here, all these three factors. That gives us as 4x squared plus 6x plus 2x plus 3 times 2x plus 5 equals to negative 105. Okay. Now I'm going to expand this again, multiply it with that. But before I do that, I'm going to simplify this one. Makes it a lot easier. So 4x squared plus 8x plus 3 times 2x plus 5 equals to negative 105. Now I'm going to expand this all over again. Okay, I'm gonna do this one first. 4x squared times 2x, that's gonna be 8x cubed. And then that's gonna give us 20x squared. Now I'm down to 8x. It's gonna give us 16x squared plus 40x. And then these two, 6x plus 15 equals to negative 105. Okay, let's collect the like terms. 8x cubed plus 32x squared plus 46x plus 15, and then bring this to the other side, plus 105 equals to 0. Okay, that gives us 120. Okay, so what we're gonna do is we're gonna factor this out. How do you factor that out? Which number do we start with? Now we'll look at the factors of 120, right? 120. We could do that. That's going to be a lot, right? A lot of factors of 120.
Let me ask you, 20x squared plus 16x squared is 32. It's 36, not 32.
Yes, it is 36, and I noticed something too. Sorry, thank you. And I forgot the other one there, 36. There you go, thank you for pointing that out. Oh, and I forgot there too. 46. Okay, so 8x cubed plus 36x squared plus 46 plus 120. Yeah. Okay. Now it's such a big number, right? Before we carry on, here's what we're going to do. Do you notice that they're all even number? They're all even number, right? 8, 36, 46, 20. They're all divisible by 2? By 2. Yeah. So what we can do is we can factor out the 2 to make it easy for us. I'm going to give us 4x cubed plus 18x squared plus 23x plus 60 equals to 0. Okay. Okay, I don't have a lot of room in here. Now we're supposed to factor this out. How do we factor that out? What numbers should we use? Now these are all positive. To make it 0, it has to be negative. Okay. Yes, fine. I don't have room for this one. Back up here. What should we try? 2 minus 2? Okay, let's try minus 2. P of negative 2, or polynomial, negative 2. What does that equal to? I got a not 0. I got a 54. Okay, so this is not a factor. Okay, what can we try? -3? Let's try -3. Okay, no, I didn't get a 0 either. Got a 68, so no. Did you get a 68? When you tried -3? Oh, I got 45. Should be 45. Did you try P of -4? Try negative.
Zero, yeah, -4.
Yeah, oh, -4. Okay. Zero. Okay. Okay, so -4 works. So what does that mean?
It's factor.
What's a factor? Therefore, x plus 4 is a factor. Okay, we found one factor. We got to figure out the other two. Okay.
So we have to take the original.
Is this a nice factorable thing? It's going to give us a 60. 60 that adds up to +2. Is there such thing? Is it 4 times 15? It's going to give us a 60 that adds up to 2. It's no more factorable, right? So the only factor, the only x is,
What about we can factor with the quadratic equation?
yeah, we could, but it's not gonna give us an integer. Yeah, you're right, we could, yeah. We could try that the 4x squared plus 2x plus 15. And then you learned this in grade 11. Negative b plus or minus root of b squared minus 4ac. Yes? You learned that? Quadratic formula?
Yeah.
No? Okay. Now, in this quadratic formula, if we put those values in, negative b, negative 2, plus or minus root of b squared, so 2 squared, minus 4, a 4ac is 15. I already see a problem in here.
It's negative.
Do you see?
This indiscriminants are negative.
Yeah, you're gonna end up with a discriminant that's a negative.
That's why I'm also.
Okay? The discriminant is negative, that means no solution. No solution. So that's a grade 11 stuff. So there's no more, this is not a factorable thing. There's no solution. There's no x value that will give us a 0 there. So the only thing is 4, negative 4. So if x is negative 4, now if x equals to negative 4, what is the first odd number? 2 times negative 4 plus 1. That's going to give us
7.
negative 7. Okay? That's our first odd number. What's our second odd number? 2 times negative 4 plus 3.
5.
That's going to be negative 5. And then the third odd number would be 2 times negative 4 plus 5, negative 3. So these are our 3 odd numbers. The 3 consecutive odd numbers are negative 7, negative 5, negative 3. Does that multiply
Yeah.
to negative 105?
Yeah.
Yeah.
7, 5.
It's like negative 7 times negative 5 times negative 3.
Times 3.
Negative 105. Okay. Okay, I think what we'll do is we'll take a break here. Okay, so take a quick break, 5 minutes.